So you're working with Data Factory, and I had to show you, how the data flows work. So let me launch the studio. So now we'll start seeing the different type of transformation, right? And there's a lot that you can do with the, you know, data flows. So if I go to data flows, go to author and open data flows. So until now we've seen pipelines, we've seen data sets. All right. Now coming to data flow, if I create a new data flow, I can have multiple sources for it, right? So let's add a single source here. I'll call it source one, and we'll create a data set for it. Okay, it does not exist already. So it's in my not blob storage, my data lake. Click on continue. Let me check my data lake till then. So demo data lake, data storage, I'll go to the container, data container here. And we have multiple CSV files here. We have text file also. We have CSV files also. I'll get rid of this text file. Or I'll just delete this because there's nothing actually within that file. And we wanted to work with these 5 files: customers, orders, products, stores, right? This is the data that we want to work with. So I'll select delimited text, click on continue, right? And so what I'm creating right now, let me show it to you, is a data set, right? Now, until now, we've seen various data sets, right? They are the standalone reusable objects that we are defining within the data factory, right? And it represents a schema, it represents a format, it represents a location as well, right? Data set is nothing but a combination of location, format, schema. Are you aware, Ravi? Is that clear? There's no confusion in that part, at least.
Yes, yes, Reyes.
Correct? Because when we are defining the data set, we also include linked service. So therefore, location is there.
Yes.
After location, we define, the location is basically to the storage service. After defining the storage service, we define which database to select or which table to select or, which container to select. So location, we are already giving. Then we are selecting the type of the file, whether it is a CSV format or a
Hmm.
Parquet format. And then we are defining the format. We are also
Yeah.
defining the schema of the data, right? It's getting the schema
Yes.
from the connection itself. So data set is where I am defining the schema and everything, the location, right, of either the data source or my sink, right? It's either my destination or my source, right? It can be reused. Data set on the left hand side
Yes.
can be reused, right? They are designed to reuse across multiple activities. You can use it in copy activities, lookup activities, right? And it connects to the same source data again and again, right? The schema also, it have a predefined schema where I can import the schema manually. I can define the schema, schema manually also, right? And they are managed as a separate object. So if I see here, my pipeline is here and I have a separate object, right? Data set is considered as a separate object.
Okay.
If I select inline, now, have you ever worked in web development, Ravi?
Web development, but I have idea. I don't get a chance.
Okay. Do you
Mostly
know that
development and this.
do
Yeah.
you know that there is an HTML file and there is a CSS file?
Yeah, those I know. Yeah.
Right? Very basic.
Yes, yes,
When
yes.
I do not have a dedicated CSS file, I define something called as inline CSS. That is defining
Yes.
the styling within the HTML file itself. Correct?
Okay.
You're aware of that word, right? Inline means that you're defining it within
Yeah, yeah.
the HTML file itself, right? I don't have a dedicated CSS file. So the
Mm.
same way, if I select inline dataset, right, that is basically defined within the source or the sink of the data flow activity. So when I'm creating a data flow, if I select inline, so that will be defined here itself within this source. It will be defined. It is non-reusable. Inline data sets cannot be reused. It will not be created over here. All right. Data set, on the other hand, is reusable, right? So it's not created as a separate reusable object, right? It is very specific to the data flow where I'm defining the source, where I'm defining the data set. It will be defined there itself and used there itself. They are not intended for reuse outside the specific data flow that we are working with. All right. and they don't have a predefined schema also. The schema can be inferred or imported based on the source data that we select, or the projection that we have selected. So I'll click on new, I'll select the data lake, click on continue again, select my delimited text file, click on continue. I already have a link service to the data lake, right? And I'll select a particular file. Let's say I want the data. Let me go to the data container. From which file shall we select? Let's select the order file. Okay. So orders.csv. Click on OK. So this is done. I'll click on OK. Now what it does, it will fetch the details of that file over here in this source. All right. So in data flow, the first thing that I'll always have is the source itself. Now you can do a lot of things with source. All right. There's something called as a source option. If there is a wildcard file path that I want to select from the source, I can do that. The main part is projection here. All right. So if you see, there is a column name that is being fetched from my source file itself, the type of that data within my source file, and then there is a format, right? So currently there is no specific format to this, right? If I want to give it some other format, all right, which activity or which function can I use? I can use this cast function, right? So if I select cast, right, there are columns which I can specify the format here now, right? I could have done it there also, right? Let me show you how to do it without this. If I, where did it go? Delete this. If I come here, right, in the source, I can change it from here. I can say that this should be taken, order ID should be taken as an integer, right? Customer ID should be treated as an integer, right? Store ID again should be treated as an integer. All right. Then when I do the data preview, I'll have to turn on the data flow debug mode. But before I turn it on, I'll have to tell you also what the data flow debug mode is. All right.
Okay.
Let me see. The projection is fine. Sorry. Let me open the PPT. Oh, 1 second. Before we go there, right? Let's talk more about the projection, right? So now here, if I go to optimize, I see something called as partition, right? Now partitioning is a concept that you would have heard about, a lot of time, correct? Yes or no? So why should we partition our data, right? Before you understand how the data flow runs behind the scene, you also need to understand a very simple and powerful idea, that is partitioning. Partitioning basically means that you are splitting a big data set into smaller pieces, all right, or smaller parts that we call as partitions or individual partitions. It's like cutting a very large cake into slices so that people can eat them at the same time, right? Without slices, only one person could start eating, and then when they finish, then the second person would come, and then when they finish, the third person. Or if you want to make a mess of it, everybody could join in together and eat the cake, right? But that would be really messy, right? So what we do, we cut the slices and we distribute it to people, and then within 5 minutes they're done, right? So with slices,
Yes, yes.
people will eat in parallel. So partitioning also
Yeah.
helps you or helps the system to process the data in a very fast and efficient manner, right? So a partition is nothing but a logical chunk of your data. It is not always a separate physical file on the storage. All right. Sometimes it will look like that it's a separate file in the storage, especially when we work with partitioning in Spark and everything, right? So you'll see in Delta table format also, multiple files are saved or multiple partitions are saved separately. So it's basically a way for, the processing engine, which is in our case going to be Apache Spark, because I've already told you that in mapping data flow, whatever transformation you define gets converted into Spark code, and behind the scenes, there is going to be an Apache Spark cluster that is going to process my data. So Spark code to process the data on the Spark cluster. All right. Now, Spark cluster is basically an architecture, right? So if I have to quickly show you what the Spark cluster looks like, let me open it. All right. So I'll give you a brief idea about Spark because it will be used in data flow. So I'm not sure how helpful it would be to talk about those concepts without you actually knowing what it actually is, right?
Mm.
So earlier what happened was we had Hadoop, correct?
Yes.
Hadoop was my initial big data processing system framework. Have you worked with Hadoop? Yes or no?
No, no, no. I haven't worked with Wado. I was a
All right.
development and DevOps only.
Oh, all right, all
Development,
right.
testing, and DevOps. Three variations I have done. Java development. After that, I was in Serena automation, and then
Mhm.
DevOps. Now I move to data analysis.
All right, understood. So now, when the big data processing started with the advent of Hadoop, right? So Google released these papers on Hadoop, and they created something called as a map reduce function or a map reduce framework. Now, this map reduce framework was basically how you know we try to process the data. What is this map reduce framework? It is basically a way of processing your data by actually creating your or distributing your data over multiple nodes. So for the first time, we discussed the distributing computing framework. All right, you understand what distributed computing is? No? All right. Distributed computing means that instead of using one single large machine, I use multiple smaller machines. All right. So rather than putting 1 TB of data here, I could give 10 GB to each machine, which can process it in parallel, right? And then they will all combine their results. So mapping was meant to be how you distribute this data onto multiple. These were called as nodes, right? So your
Yes.
distributed computing architecture would have nodes.
Okay.
Together, these nodes would create something called as a cluster, correct?
Yes.
Together, all of these machines are called as a cluster of machines. So map reduce is the way to process this huge amount of data. What they were doing, you know, we know why it was created. So first was the map step. Map basically meant to break down the data. All right. The map function takes the big data and breaks it into the smaller chunks, right? Those smaller chunks will now be sent to these individual machines to process. All right. Each chunk is processed separately by different computers. The output of this step, the mapping step, right, once it is processed, is usually in the form of key value pairs, right? So if you want to count how many times a particular word appeared in the book, right? So each computer will look at only certain pages, not the entire book. All right. And every word it sees, it will say that, let's say how came. So there's a how, comma one. This one is basically the count of how many times this word appears, right? So label, comma, count. If how comes again, I will update this to how, comma, two, right? So this is how it used to do. So map function, you just have a lot of small, different data sets created out of your bigger data. The reduce step was basically when 20 computers are there in the in the cluster, and they have calculated how many times a particular word how appeared, right, individually. Now it's time we basically combine all of that, because if I want it for the entire book, I'll have to combine the results towards the end, right? For example, each node was taking a look at 100 pages and book was 1000 pages. So those 10 computers who performed the analysis on all the 1000 pages, in the end I will have to combine the result. So that was the reduce phase, where you would actually combine the result. All right. So that was the map reduce. But there were a lot of problems with Hadoop. All right. Hadoop had a lot of problem. First one, it was very difficult to write your map reduce jobs. It was very complex. All right. So it was a very complex task. People found it really hard uh, to basically write these programs to for the map phase and the reduce phase, right? Now the second problem was that any intermediate data was being stored in the storage or disk. All right, any data that had to be written was being written to the disk, and if it was had to be reused, it was being read from the disk as well. Now reading and writing data again and again to the disk, is it a simple process, is it a slow process, or a fast process? Yes or no? Is it a simple process or a fast process, fast or a slow process? So reading and writing from the disk is fast, so is a very slow process. All right, this is what we wanted to make fast,
Yes.
and that is where Spark or Apache Spark came into the picture.
So Spark means it distributing the.
Spark also uses distributed computing. Both Hadoop and Spark both use distributed computing, but what Spark introduced was that this Java code that you have to write, very complex Java code, it gave multiple options. You can interact with the compute using Python, that is
Python,
PySpark.
Scala.
You can write Scala code. If you know Java, you can write Java also. If you want, you can deal with it using SQL also, right? So now it is not required for you to only know Java to work with the distributed computing in Hadoop, right? So one problem it solved, correct? The
Yes.
next problem that it solved was that the slow process of reading and writing data from disk, it introduced something called as in memory processing. All right. So now the data was processed in RAM, and getting or reading or writing data to the RAM, it turned out to be in some cases 100 times faster. All right. In some cases, it turns out to be 100 times faster than the MapReduce. All right, or the MapReduce framework. So using Apache Spark, we were able to achieve speed of data processing that was 100 times faster than Hadoop. All right. And what Apache Spark introduced? The same distributed computing. It had a cluster, right? The cluster would have multiple computers. It's a very simple architecture if you understand, right? And then it will have something called as a master also, or a driver computer also, right? So one computer was called as the driver. The rest were called as the workers. All right. And individually, these computers are called as nodes. Correct. So now the driver would get the code along with the data. It will break down my large piece of data into smaller pieces. These smaller pieces will now be sent to these individual computers.
Who is taking care to create small pieces?
This
Nodes.
driver,
Driver. Okay.
driver, the
Master
driver will be
driver.
responsible. Yes. So we have a driver node here who will break this data down, send it to different workers along with the code.
Okay.
Code is
In
nothing.
PySpark, for example, if you take in Python, if we are in PySpark, we need to be write that differentiation in the code, right?
No, you don't have to select it. The system will define
Okay.
it. That's the job
Okay.
of the architecture. All right.
Yes. We'll check.
That
Okay.
will
Got
happen
it.
in the backend itself. You don't have to select anything. If you have
Okay.
provisioned nodes, you will be provisioning one, driver node and multiple executor nodes. I'll show you. So this transformation logic was written through the code. My PySpark code is nothing but me telling, Apache Spark as to what processing has to be done, where the data is present, what is the format of the data, what you have to do, how you have to create the data frame, what transformations you have to do on that data frame, whether it's a filter, whether it's an aggregate, whether it's a sum, whether it's a max, whether it's a conversion or something. I will define all the transformation logic in the code. So along with code, the data was shared, and all of these computers would independently now process my data. And then once processed, this data will be sent back to the driver. All right, understood? All of this data would be then sent to the driver, where the driver would combine it together as the output data. Clear? Make sense? And it'll output the data. Now, there are multiple more parts to it, but this is a very simple definition of how it does it. So all of this processing of the smaller data set, it happens in memory, in the RAM. I am not reading or writing data to the disk at any given state. All right. Everything is read from the memory, everything is written, intermediate data is written to the memory, and then eventually it reaches the driver. So this architecture where there is one master and multiple slaves listening to the master is also called as a master slave architecture. All right. It's called as a master slave architecture. Have you heard about it?
Yes, yes, right.
All right.
Master is
Now
like
there
a
are
driver,
master is who
master is the
controls
driver, and
everything. Yes,
slaves are
exactly.
like a nodes,
Workers, right?
workers. Yeah.
Now you would hear two things: workers and executor also. Sometimes these two words will be used interchangeably. What it actually is that a worker node, if there is a worker node, this node will run something called as an executor program. All right. This executor program is where the data will be processed and everything. Will get into the depths of it as to what this executor program is, what does the executor program do. The executor program is basically, interacting with the cluster manager, right? So when we get into the depth of it, you will realize that instead of driver directly talking to the workers, what we actually have here is something called as a cluster manager. You would have had some idea about Kubernetes, right?
Yeah, I have some idea.
Yes. So Kubernetes
Yes,
is also a cluster manager. It helps you manage your nodes, correct?
yes, yes. There is a
So the
lot of
same
containers.
Kubernetes could be used in Apache Spark also to manage this cluster of workers. All right.
Okay.
So there is a cluster manager who talks to these nodes and then lets the driver know that, okay, we have some empty nodes, we can utilize it. Please send me the data along with the code. The driver sends it to the cluster manager. The cluster manager will take a look. If, for example, any of the node fails, right? If any of the node has failed, cluster manager will inform the driver that this node has failed. Whatever data you had shared there, please send it again. I'll give it to some other node. So it's basically a communication that happens between the driver, the cluster manager, and the nodes, right? So there are many cluster managers. There's something called as Apache Mesos. There's Kubernetes. There's Yarn. By default, there is Yarn. Have you heard about Yarn? Yarn is nothing but yet another resource negotiator. It is used in Hadoop also. Yarn is
Okay.
used in Hadoop, right? So multiple are there. Uh, you have some native cluster manager also. You don't have to select a cluster manager dedicatedly. My Spark architecture will come with a cluster manager. So if I have to just show you quickly how the Spark cluster looks like. If I go here and let me see if I have a Synapse workspace ready. If not, I'll create one quickly to show it to you. What happened? Okay, this is the problem I'm facing with Azure. Let's create one because we'll be using it. Password for the SQL server that will be created to host the dedicated SQL pool. We've already seen this and we'll create it. Let this deployment be completed. So I'll show you. Meanwhile, here, right, we are talking about partitioning.
Yeah.
So now you understand, right, why partitioning is
Yes.
important,
Shreyan,
right?
for
Mm.
this, we can create all these for this free subscription also we can do.
Yes, 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 yes. You can do that.
But he's showing some charge, right? So that's the reason. Is there any amount deduction taking place or something?
Where is it showing the charge?
Okay.
No, no, I'm asking where did it show the charge while creating the resource?
Yeah, while
To me, it
creating.
will show, right? I don't have
Okay.
credits, so to me it will show. For you also, it will
Okay.
show,
Okay.
but you have credits, right? It will deduct it from the
Yes. Yes.
credits.
Yes. Yes. Okay. Got it. Thank you.
All right. Now the thing is, when the Spark does this partition, right? I told you that Spark will come into the picture because mapping data flows uses, Apache Spark under the hood. So
Yes.
you do not manage the Spark cluster directly. ADF will spin it up in the backend and help me with the processing, right?
Okay.
So you'll have, let's say total you have 8 cores, right? So it could be that driver will have 4 cores, workers will have 4 cores, right? Now, if you have, let's say, 8 partitions of your data, right? If you have a single partition, if you use or if you set partition, right, in the round robin manner, or if you want to have a hash, partitioning, dynamic ranges there, fixed ranges there, key based partitioning is there. We'll come to all of this, right? But when you do this partitioning, if let's say there are 8 partitions in total that you want to create, right, and there are only 4 worker cores. So what happens? Let's say one worker has 1 core. So first your 4 partitions will be processed, then the next 4, right? That is why, by default there are total of 8 cores. So that is why you'll have to select the number of partitions and everything very, uh, you know, uh, with a lot of consideration, right? Now there are two purposes. One is source partitioning, one is sink partitioning, right? So in data flows, under the optimize section, we'll see the partitioning. Now this partitioning could be done for the source also, for the sink also. Source partitioning will basically control how the Spark will read and process the data during any transformation, right? How does it impacts the performance? Sink partitioning will control how Spark organizes the output data. All right. In the folder, wherever I have, let's say I have the output location, wherever it is, wherever my destination is, how it will be organized in the destination. That is sink partitioning. Source partitioning is basically you telling Spark how to read this data, read it in partitions, don't read it all together, right? So source partitioning is done for performance during compute, whereas sink partitioning is done for structuring the final data. Make sense? Yes or no? Now, by default, it will always be under use current partitioning. All right, that is the default behavior. If your source, that is a file or a table, already has a partitioning information, if there is already a partitioning key, right, Spark can leverage that. If not, Spark may treat the entire data set as one single partition, especially if it's a small data set, right? Now, when to avoid or what is this single partitioning? Single partitioning will force everything into one single piece. This will make sure that your source is read as one single input file. It is only nice when you have tiny data set, when you're testing, when you're debugging your pipelines, right? And when you absolutely must have a single output file name. For that case, single partitioning is fine. For large data sets, it will slow down the execution. Then you have, you know, so main choices, you have use the current partitioning, where you do not do anything special. Whatever already exists is used. If there is a partitioning there, it will be used. Single partition will force everything into one single big data, right? It is bad for big data, okay for small outputs, right? And then there is finally something called as a set partitioning, where I have multiple strategies of partitioning, right? Round robin is basically it will evenly spread the rows across the n partitions. All right. If I say that my data should be read in 5 partitions, So the first row will be sent to partition number 1, the second will be sent to partition number 2, third to 3, fourth to 4, fifth to 5th, sixth again to first, seventh to second, eighth to third, ninth to fourth, 10th again to fifth one. So that is how the round robin works, correct? The hash partitioning, it uses a hash or one or more columns, right? Why it does that is, right? If I can select on which column do I want it. Let's say I want it on store ID, right? Now what happens is I can have, let's say, 5 partitions. So what it will do, it will try to group all the rows with the store ID similar into a single partition. All right. So identical values will end up together. It is really good for aggregations and joins, but and all it is also good when you have to search your data in the destination, right? So and when I'm searching for the data in the destination and I know that it belongs to a particular partition because my store ID is this, then searching becomes easy. There is a key based partitioning, right? It explicitly chooses a column, so rows with the same value go into the same partition, right? There is something called as a dynamic range also, where Spark will estimate a range for a column and group values into a balanced partition. All right. It is useful for numeric columns with somewhat even spread, right? So you can select the column which you want. And then there is a fixed range also, where you define an explicit value, right? Let's say from 0 to 999, right? uh, Over here you'll enter the expression, right? Where you select values from 0 to 999, then 1000 to 1999, 2000 to 2999. So it's good, when you know the data distribution, right? So if we have, a table, let's say with customer name, city, and a region, and there are 10 million rows in total, right? And there are only 3 regions there. Let me show it to you.